Dear all, this is Ambalatharasu, Assistant Professor, Department of Science and Humanities, King's College of Engineering. Now we are going to see about bimetallic strip and some fundamentals required to know details about bimetallic strip, which is in thermal physics, engineering physics. Just we need to know about some introduction, that is thermal physics, which is a field deals with science with heat and temperature. The study of thermal physics is important because of various application in engineering as well as day-to-day life. So, transfer of heat might be through three processes. That is, heat transfer from one place to another place in three respective ways. That is conduction, another is convection, and finally radiation. Here I have given a very simple example. Normally a stove with basin with water while heating. This is conduction, and inside the water molecule heating gets heat and boiling, which seems to be convection, and the heat surrounding the stove is called radiation. So, if we need to know about in definition, conduction is the transfer of thermal heat through direct contact. That is like heating a rod in one end. Next, convection is transfer of thermal energy through the movement of a liquid or gases. For example, boiling water. Next, radiation is transfer of thermal energy through thermal transmission. The same example in another simple way. Conduction, a rod is getting heated on another end while heating at one end. Next, convection, the transmission, that is like what we say water vapor. Similarly, next, radiation. There is an experiment also for thermal expansion. The expansion of metal when subjected to heat is called thermal expansion. The force or stress developed inside the metal so as to regain its original position is called thermal stress. This example we can clearly get about an idea about thermal expansion. Also in liquid and gases also the same happen. The best example for this liquid is milk. While heating it expands, that is the expansion of liquid completely, the entire level will increases. Another say expansion joints. What is mean by expansion joint? Before entering into that, we see some examples which can clearly indicate the ideas. That is, in railway tracks, there is a joint. Also nowadays we can see in national highways or any bridges, there is a joint like this in which they use steel or metal with the rubber capable by capping that, like that. We can see this everywhere. What is the use? That is, area is less than the force required to restore the material to original position is less. Suppose if the area is large, then restoring force should be more, which is quite impossible. Hence, to avoid this problem, while constructing a large area of beam or bridges, gaps are provided, and these gaps are called expansion joints. Already we said about the examples. Next, now we comes to the actual topic, bimetallic strip. From the name itself, it clearly indicates that bimetallic strips, that is made up of two thin metal strips with different thermal coefficient. That's all. Very simple. For example, iron, copper, which has different thermal expansion coefficient, or brass, like that. We can use any material of different thermal expansion coefficient. Okay. How it fabricate? Let us consider two metal. A brass of higher coefficient of thermal expansion and steel of lower coefficient of thermal expansion. So actually what happens, if we heat any metal, it gets expands. This expansion level is up to the thermal coefficient. So brass and steel jointed here. After heat, this bends like this. Why this happen? Because brass of higher coefficient. Next, coming to cooling. While we cool, bend in this direction because of lower coefficient of thermal expansion. This is the experiment as well as many day-to-day life activities utilization. While heating, the bimetallic strip is heated, then the strip will start expanding, and therefore the brass, which has larger coefficient of thermal expansion, gets expand more than the steel, and hence bimetallic strip bends like arc. While cooling, bimetallic strip is cooled, then strip will start contracting, and therefore brass, which has larger coefficient of thermal expansion, contacts more than the steel and bend like an arc. Similarly, here a copper and iron diagram is shown here. Properties: coefficient of thermal expansion, which is defined as change in physical property of the metal in response to change in temperature like shape, area and volume. Next, elasticity model, which is the ratio of stress to strain in elastic deformation region. Elastic limit on cooling, it is the standard limit at which the metal get back to its normal states on cooling. These properties varies from metal to metal, that is like copper, iron, aluminum, brass, etc. Electrical conductivity is the amount of current passing through the material, and the material is ductile, metal grade, so these study of bimetallic strip is application in various field of engineering. Now, one of the best example is given here. We all know about fire alarm. How this fire alarm works? When the temperature rises, here we shown a candle. If it is glowing, the temperature nearby will rises, and here the bimetallic strip, it gets bent or seems to be like arc. Then the conductivity or gets connected, and the alarm will ring. A fire alarm uses bimetallic strip to ring the bell. In this way, we are using fire alarm. Also, many other applications used in clocks, thermistor. Already we know detail about thermistor. That is, with respect to heat, it changes its resistivity, iron box. Nowadays we are using modern iron box with weightless technology and automatic. This automatic switch, they used bimetallic strips. Next, similarly, heat engines, water heaters used in our homes, fire alarm already we have discussed. Thank you. Thank you all.